welcome to RankLens. Today, we count down the top 10 greatest scientific predictions that were eventually proved right. Science isn't just about testing ideas, it's about predicting futures so precisely that reality bows to the math. From comet returns to particle discoveries, some of history's boldest predictions came true with stunning accuracy. These aren't lucky guesses or vague hunches. These are scientists who dared to forecast the unforeseen, who calculated what nobody had ever seen and staked their reputations on the answer. The wait times ranged from months to a century. Here are the 10 greatest scientific predictions that actually came true. We're counting down from number 10 to the one that might surprise you. Let's begin. At number 10, the return of Halley's Comet, predicted by Edmond Halley in 1705. Using only Isaac Newton's brand new laws of gravity and motion, Halley did something almost unthinkable. He calculated that a comet he'd observed wasn't a one-time visitor, but a regular traveler through our solar system. He predicted it would return in 1758. The remarkable part? Halley himself died in 1742, 16 years before his forecast would be vindicated. He never lived to see his prediction proved right. When the comet reappeared exactly on schedule, 18th-century astronomers were stunned. Here was Newtonian mechanics working so precisely that it could predict cosmic events decades in advance. It wasn't just a triumph for Halley, it was proof that the universe ran on mathematics. At number 9, the bending of starlight by gravity, Albert Einstein's 1915 prediction. Einstein didn't just say gravity would affect light, he predicted exactly how much. His general relativity equations said the sun's gravity would bend, passing starlight to a precise angle, twice what Isaac Newton's older theory would predict. The test came on May 29, 1919, during a solar eclipse. British astronomer Arthur Eddington led an expedition off the coast of Africa to measure starlight bending around the eclipsed sun. What he found matched Einstein's prediction almost exactly. The result was electrifying. Relativity wasn't just elegant math, it was true. Einstein became an overnight global celebrity, the first scientist to achieve worldwide fame for pure theory. Gravity didn't just pull objects, it curved space itself. At number 8, the discovery of Neptune through pure mathematics, predicted by Urbain Le Verrier and John Couch Adams in 1845. Astronomers had noticed something odd. Uranus wasn't orbiting exactly where it should. Its path wobbled slightly. Two mathematicians independently asked the same question. What if an unseen planet was pulling on it? Le Verrier calculated where this invisible world must be. He didn't observe it, didn't see it coming. He calculated its position from gravitational mathematics alone. On the night of September 23, 1846, German astronomer Johann Gamow pointed his telescope at Le Verrier's predicted location. Neptune appeared within 1 degree of the forecast. 1 degree. It was the first planet discovered not by accident, but by mathematics. In a single year, prediction became reality. This wasn't luck, it was the power of understanding gravity itself. At number 7, Dmitri Mendeleev's predicted elements, announced in 1869. Mendeleev built the periodic table, but he left gaps. He refused to squeeze elements into wrong positions just to fill the grid. Instead, he claimed these gaps represented undiscovered elements. He predicted their atomic weights and chemical properties with remarkable precision. He called one Ica aluminium, guessing it would sit between aluminum and tin. Then gallium was discovered in 1875, matching his forecast almost perfectly. Scandium followed in 1879. Germanium in 1886. All three matched his predictions so closely that skeptics became believers. Mendeleev hadn't just organized known elements, he predicted unknown ones by understanding the deeper patterns of nature. At number 6, the neutrino, postulated by Wolfgang Pauli in 1930. Physics had a problem. In radioactive decay, energy seemed to vanish. Conservation of energy, one of nature's fundamental laws, appeared broken. Pauli made a radical proposal. An invisible particle, one that barely interacted with matter at all, was carrying away the missing energy. He called it the neutrino, the little neutral one. Detection seemed impossible. The wait stretched decades. Then, on June 14, 1956, physicists Frederick Rains and Clyde Cowan finally detected neutrinos near a nuclear reactor. 26 years after the prediction, the neutrino was real. It turned out they were everywhere, billions streaming through your body every second, passing through solid rock without ever touching it. Pauli had imagined something invisible to save the laws of physics. Reality agreed. At number 5, the cosmic microwave background, predicted by George Gamow, Ralph Alpher, and Robert Herman in 1948. They asked a radical question: if the Big Bang was real, what happened to all that heat? Their answer: the leftover radiation should still be there, filling all of space, cooled by the universe's expansion to a very specific temperature. They predicted it would be just 5 degrees above absolute zero. For 16 years, nobody looked for it. Then, in 1964, Arno Penzias and Robert Wilson were cleaning an antenna at Bell Labs when they detected a mysterious signal. It was everywhere. It was uniform. It was exactly what Gamow, Alpher, and Herman had predicted. The discovery didn't just confirm the Big Bang, it made it irrefutable. The universe itself was ringing with the echo of its birth. At number 4, the positron, predicted by Paul Dirac in 1928. Dirac was a mathematician working with a deceptively simple equation describing electrons. The math had a strange feature: it described not just one type of particle, but 2. The second one was the electron's mirror. Same mass, same spin, but opposite charge. The anti-electron. Dirac insisted it must exist, even though nobody had ever seen it. He was right. In 1932, just 4 years later, Carl Anderson was studying cosmic rays when he spotted the positron's track in his cloud chamber. It matched Dirac's prediction perfectly. Here was matter with an antimatter twin. Later, scientists would realize whenever matter and antimatter collide, they annihilate in pure energy. Dirac had imagined an entire new form of existence from pure mathematics. At number 3, the Higgs boson, proposed by Peter Higgs and others in 1964. Most particles have mass, but why? Higgs proposed a field pervading all of space. Particles gain mass by interacting with it. The field itself would have a particle, the Higgs boson. For 48 years, scientists searched. Experiments grew larger and more powerful. Then came the Large Hadron Collider at CERN, the most ambitious physics machine ever built. On July 4, 2012, CERN announced discovery. The Higgs boson was real. Its mass, properties, decay patterns all match theory's prediction. The discovery earned Peter Higgs and François Englert the Nobel Prize. The media called it the God particle. For nearly half a century, one particle had eluded discovery. Then, theory proved triumphant. At number 2, the Bose-Einstein condensate, predicted by Satyendra Nath Bose and Albert Einstein in 1924. They asked, what happens if you cool atoms to near absolute zero? Their mathematics gave a stunning answer. Atoms would lose their individual identity and merge into a single quantum wave. A whole new state of matter, predicted from pure statistics. For 71 years, nobody could test it. Cooling atoms to such extreme temperatures seemed impossible. Then, in 1995, 3 physicists achieved it. Eric Cornell, Carl Wyman, and Wolfgang Ketterle finally created the first Bose-Einstein condensate. The atoms behaved exactly as Bose and Einstein had predicted. They merged into a single quantum entity. The 3 scientists won the Nobel Prize in 2001. 71 years. That's how long it took for theory to meet reality. At number 1, gravitational waves, predicted by Einstein's general relativity in 1916. Einstein's theory said, space-time isn't a fixed backdrop, it's flexible. Massive accelerating objects would send ripples through space-time itself, waves of gravity traveling at light speed. But detecting them seemed impossible. You'd need instruments of extraordinary sensitivity, sensitive enough to measure vibrations smaller than a proton. For 99 years, the prediction stood. Then, on September 14, 2015, LIGO detected it. Two black holes, a billion light-years away, were spiraling together. As they collided, they sent gravitational waves screaming across the universe. LIGO caught the signal. The waveform matched Einstein's equations with astonishing precision. A century after prediction, general relativity had been vindicated in the most extreme way possible. The universe spoke in gravitational waves, and we finally learned to listen. What do these 10 predictions teach us? They show that science's greatest power isn't explaining what we see, it's imagining what we don't. From Halley calculating a comet's return centuries away to LIGO hearing gravitational waves from across the universe, these scientists trusted math and logic over intuition. They were willing to be wrong. They staked their reputations on bold claims, and time proved them right. But here's what's humbling. We don't know which of today's theoretical predictions will stand the test of time. Right now, physicists are making guesses about dark matter, string theory, and the shape of the universe. Some will be vindicated. Some will fall away. The scientists making those predictions today are in the same position Dirac and Einstein once were, gambling that nature favors their mathematics. That's the enduring lesson. The universe is stranger and more precisely ordered than we imagine, and science is our best tool for listening to what it's trying to tell us. And that's the top 10 greatest scientific predictions that were eventually proved right. If you enjoyed this countdown, subscribe to RankLens for more.